Okay, college algebra, this is problem 8 on the practice review. This is the problem where you basically got 6 functions, 6 graphs, and your job is to match them up. And what I would tell you is these things they come in pairs. If you'll notice, you've got 2 quadratic, 2 cubic, 2 square root, and if you look at the graphs, you've got the same thing. You've got 2 parabolas, 2 cubic graphs, and 2 square root graphs as you look through those. So the trick really is to distinguish each of these two. I would highly recommend, you guys know a lot about transformations by now, you know about parent functions, you know that these first two are going to look like parabolas of some kind. You know this one, because it has a leading positive coefficient, is going to open up. Not only that, you know it's going to be shifted right 3 and up 1. So you just kind of make a mental note, this thing's going to look something like that. This thing has a negative leading coefficient, and it's down 4, so look for something like that. Just kind of make a note. What am I looking for? What distinguishes the two? One opens up, one opens down. It's probably enough. Here's a cubic, positive leading coefficient, shifted left 2 and down 3. So don't worry about that 2. It's going to make it a little bit skinnier, but holy cow, we're talking about a cubic function and they're already pretty thin, right? So this thing's going to look something like this, right? Where the inflection point is down here. This one's got a negative, so instead of starting low and going high, essentially it's going to start high and go low, and it's shifted up 1. So you'd expect the x-axis along here somewhere. Okay, so just give yourself an idea. How can I tell those two apart? Square root functions. This one. This one is a square root function. It's shifted down 2. This one is a square root function. It's not shifted down 2, but it is, kind of got a couple things going on here. It's flipped over the x-axis and twice as big. So the parent function. I'll draw the parent over here. Tends to look like this, right? Starts at 0, 0, and then just kind of arcs its way up this way. So this one is going to be flipped across the y-axis. It's going to flip across the y-axis and drop down 2. And that's really what you're going to be looking for. So this thing is going to go this way, and it's going to start, down a little bit. This one is not. But it's still going to be flipped over the x-axis. It's going to flip it over the x-axis and make it a little more exaggerated. It's going to flip over the x and be more like this. And so now it's just a matter of matching these up. So you can easily match up A. Certainly goes with this one. You can see it opens up. It's a little over to the right and up. Right? So this is definitely A. Where's our other parabola? Does it match? Yeah, it's shifted down and it's centered on the y-axis. So that's definitely our B. C, this is the cubic that has the normal. Well, this one's the backwards one. Here's the normal one, and as predicted, the inflection point is down here, right? So that's definitely C. That leaves this other one, right, which we predicted would look kind of like this. There it is. Looks kind of like that. So that's D. Okay, E. Start down a little below 0, 0 and then kind of curve up and to the left. And there it is right there. There's our E. Only leaves one left for F, and it should start at 0, 0 and go down and to the right. Start at 0, 0 and go down and to the right. That's what we predicted. And there it is. Start at 0, 0, go down to the right, there's F. Okay? So take your time on these. Think about parent functions, group them up, give yourself the best chance to get 100% of the points on number 8. You definitely don't want this to be one where you lose a few points. So scoop up all the points here. This one's just straightforward. Do you know your transformations and do you know your parent functions? And if you're even halfway good at those, you're going to do great on this problem.